Alright, so today we're going to look at rational inequalities. So this is going to be very similar to what we did with the polynomial inequalities. No, it does not have anything to do with Einstein's quote when we talk about the word rational inequalities versus rational thought process. Those are not the same things. I just wanted to share the quote. Okay, so first things first. Simplify this rational expression. What do we mean simplify? Well, get a common denominator, right? We've done this before. This is not a rational inequality. This is a rational expression. What makes it rational? Well, we remember we talked about rational, and conveniently I was nice enough to put the definition of rational expression on your note packet, which is right above this. So you can see rational expression is an expression in which the numerator and denominator are polynomials. What is a polynomial? Well, you should know that. So, this is a rational expression. We want to get a common denominator. Right now the denominator here is 1. So I'm going to multiply the 4 by 1 plus 2x over 1 plus 2x. Why? Because this has a denominator of 1 plus 2x. Okay, good stuff. 5 plus 7x minus 4 times 1 plus 2x all over 1 plus 2x. Now let's simplify. Notice how I wrote the parentheses around the 1 plus 2x? That's to remind me that when I distribute the 4, it is actually a negative 4. So 5 plus 7x minus 4 minus 8x over 1 plus 2x. Combine like terms. 5 minus 4 is 1. 7x minus 8x is minus x. That is my simplified rational expression. Boom. Okay, why did we do that? Because that is our first step when we are solving rational inequalities. Conveniently, I gave you the exact same inequality that we used for the rational expression on the previous problem. So, what are our steps? Again, these are in your packet, so I'm going to go through these a little bit quicker, but we'll still take our time, kind of. So first we want to bring everything over to one side and combine to a single rational expression. So in this case I'm going to make this 5 plus 7x over 1 plus 2x minus 4 is less than or equal to 0. I know from this problem that 1 minus x over 1 plus 2x is what this is going to simplify to. I'm not going to do that work again. If you need to see that, look right above. So I know this becomes 1 minus x over 1 plus 2x is less than or equal to 0. So this was step 1. Bring everything over to one side and simplify, which means combine to a single rational expression. Okay. Step 2. Similar to what we did with the polynomials, we are going to find a critical value, or critical values. So how do we do that here with the rational inequalities? Well, we actually get critical values from the numerator and the denominator separately. Remember, the numerator is a polynomial and the denominator is a polynomial. So I set the numerator equal to 0. So 1 minus x equals 0. Then I solve for x. So I get, if I add x, I get x equals 1. And I set the denominator equal to 0. So 1 plus 2x equals 0, and I get x equals negative 1/2. So these are my critical numbers, both of them. One came from the numerator, one came from the denominator. Great. Next step, again, this should be familiar now. We are going to create test intervals using the critical numbers. We want to use interval notation, just like we did with polynomials, and we also have to pay attention to, is the critical number from the numerator or the denominator? Why do we care about that? Well, let's look. So keep in mind, this was a less than or equal to problem. Okay, so that means we're going to use brackets. So I have negative 1/2, which came from the denominator, and I have 1, which came from the numerator. But what do we have to keep in mind whenever we have a rational equation or inequality or expression? The denominator cannot equal what? Very good. The denominator cannot equal 0. So if x is negative 1/2, the denominator will equal 0. So even though this is an inequality including the values, because it's a less than or equal to, when I'm writing my test intervals, the negative 1/2 is going to have a parenthesis on it because it comes from the denominator. The 1 is going to have a bracket because it comes from the numerator and because this is an equal to. If this was just a less than or just a greater than, we don't have to worry about this. Everything is parentheses. But since it was a less than or equal to, and we had a value from the numerator and from the denominator, anything from the denominator is still a parentheses, anything from the numerator is still a bracket. Okay, so those are my test intervals. So now it's the same thing as before. Choose values to test within each interval. I'm going to do negative 1, 0, 2. So now, the only thing that's a little bit different, and this is actually true for the polynomials, I just didn't talk about it that much, is I can choose either the original inequality or I can choose the simplified version. A lot of times the simplified one's going to be easier to work with because you're comparing to 0, but it's up to you. The other thing to keep in mind is you can use some shortcuts in understanding, okay, if this whole fraction is going to be less than 0, then either the numerator or denominator, one of them has to be positive and one of them has to be negative. If they're both negative, this will actually be positive. If they're both positive, this will be positive. So that can kind of help. So I'm going to try each of these. So if I do 1 minus negative 1 over 1 plus 2 times negative 1, this becomes 2 over 1 minus 2 is negative 1. This is less than or equal to 0. So that's true. If I do 1 minus 0 over 1 plus 2 times 0, I end up with 1 over 1, which is 1, which is not less than 0, less than or equal to 0. So that is not a solution. And if I try the third one, we have 1 minus 2 over 1 plus 2 times 2. And so here again, I can see the numerator is negative, the denominator is positive, therefore the whole thing is negative. So I don't have to write this step of negative 1 over 5, which is less than or equal to 0, but I'm writing it for your practice. However, if you realize earlier on that something is not going to be true or that it is going to be true, you don't have to show all of the work. Okay, and then our last step, write the solution intervals. This one we did not ask to graph, but we could graph it as well. So our solution intervals, negative infinity to negative 1/2, and then one to infinity. If we wanted to graph this, put a negative 1/2 with a parenthesis and shade to the left. Put a 1 with a bracket and shade to the right. And remember, when I say graph this, we're not actually graphing the inequality, we're graphing the solutions. It's different. Alright, I want you to try one on your own. So solve and graph 1 over x is greater than or equal to 1 over x plus 3. So follow the steps that we did on the last one. I'll give you a hint on this. It does not matter which side you bring everything over to. It's up to you. You should get the same answer either way. So pause the video, Bring everything over to one side, simplify, find your critical values, create test intervals, test your test intervals, find your solutions. Graph, unpause when you're ready, check your work. Alright, so here our solutions should be negative infinity to negative 3 and 0 to infinity with a parenthesis on everything. This is what our graph looks like. How did we come up with this? Okay, well, I chose to bring everything over to the left-hand side. So I subtracted 1 over x plus 3. Now I got a common denominator. So I multiplied the top and the bottom of this term by x, and I multiplied the top and the bottom of this term by x plus 3. So I end up with x plus 3 minus x in the numerator over x times x plus 3. You can distribute the x in the bottom if you want, it doesn't matter. This simplifies to 3 over x times x plus 3. So this is my simplified inequality. Now I found my critical values, so I set the numerator equal to 0, 3 does not equal 0, so that doesn't do anything for me, and I set the denominator equal to 0. X times x plus 3 equals 0, so x equals 0, that is a critical number. X plus 3 equals 0 gives me x equals negative 3 is a critical number. Since both of my critical numbers came from the denominator, even though I have a less than or equal to or a greater than or equal to, I'm still going to use parentheses because the denominator cannot equal 0. So my test intervals are negative infinity to negative 3, negative 3 to 0, 0 to infinity. The values that I chose to test were negative 4, negative 1, and positive 1. Now down here you can see where I tested them. I tested them in the simplified inequality. Again, if you realize right away, so for example, in all of these problems, since the numerator is just 3, that's positive. So really all I'm looking at is the denominator. Does the denominator come out to be positive or negative? Here the denominator is positive, so this one is true. Here the denominator is negative, so this is false. Here the denominator again is positive, so this is true. So therefore I got my solutions of negative infinity to negative 3 and 0 to infinity. Next one. Try this on your own. Solve and graph. It's already simplified for you. You just need to find the critical values. Alright, so our solution here is negative 3 to 0, including the negative 3, so that's a bracket. Very sloppy, but it's a bracket. And a parenthesis on the 0, so not including 0. And then 2 to infinity, again, that's a bracket on the 2. And then 2 to infinity, which is always a parenthesis. Here's our graph. How do we come up with this, you might be asking? So, this is already a simplified rational expression. Therefore, I just need to find my critical values. So I set my numerator equal to 0. It factored into x plus 3 times x minus 2. So I get x plus 3 equals 0 and x minus 2 equals 0. Therefore, I get x equals negative 3 and x equals 2 are critical numbers. I also set my denominator equal to 0. There's no work for that, so it's just x equals 0. So I have 3 critical values. So I use those values to set up my test intervals. Negative infinity to negative 3, bracket on the negative 3 because this is an equals to, and the negative 3 came from the numerator. Negative 3 to 0, parenthesis on the 0 because the 0 came from the denominator. 0 to 2, bracket on the 2 because 2 came from the numerator and this is an equal to, and then 2 to infinity. I chose negative 4, negative 1, 1, and 3 as my test values within each interval respectively. One thing I want to point out, I have not mentioned this yet, but although, for instance, this includes negative 3 in the interval, you never want to pick one of your critical values as your test value within the interval. You know what that critical value is going to give you. It's going to give you 0. That's how you found it to start. So never pick one of the critical values as your test value. Okay, so then you can see my work here where I tested each of those. The first one was false. The second one was true, third one was false, fourth one was true, and that's how I got my intervals and my solution. Last one. So I want you to, again, try this on your own. This, again, is already simplified, so you just need to start by finding the critical values and going from there. Pause the video, unpause when you're ready to check your work. Alright, so here you can get negative 2 to 0, including the negative 2, including the 0, and 9 to infinity, not including the 9. There's your graph. Here's the work. Set the numerator equal to 0, that's the 0 and the negative 2, so those have brackets. 9 is a parenthesis because that comes from the denominator. create your intervals, test them, and bam.